Hello everyone, this is our project from Group 4, the Storm Safety System, uh, which has the member of myself, Sinarjunan Prastya Jarianto, and then
and
Lintar.
Lintar Alvisha Pujo.
So for our system, our project, uh, it's designed for protects buildings for severe weather conditions. It uses sensors to detect environment changes and activate actuator for the action. So let's get into it. So this is our block diagram. And for the components, we use the microcontroller, we use Arduino. And then for the sensors, we use the FC37 raindrop sensors and the anemometer. So the anemometer design that we use is actually in the Hall effect sensor design. So it uses magnet to detect the wind speed. After that, the actuator that we use is servo motor for the windows, and the other actuator is the N20 DC motor. So this is for the roof. So for the DC motor, we use a motor driver to easily control the DC motor. So it's it should be work like this 3D model design. So when the rain pours, the roof will automatically close the front yard and cover the front yard of your home. And for the window, use the anemometer if the wind speed is exceed of the certain limit, and then the window is will automatically close. And for the market will be explained by Lintar.
In here, I will first explain about our code. So I will share my screen now. Udah kelihatan belum, John? Okay. So this is the code that we are using here. We use this is initializing the pin for the Hall effect sensor, and then the rain sensor, and then this is for the driver motor. This one it is used to count for like the time to the motor rotate. Also, we use this function void count pulse because we use a Hall effect sensor. So we need to count the pulse in a certain time so that therefore we can measure the speed of the anemometer. This is like usual the void setup here. We make the each pin input or output, and then this is our void loop. So this code is for the anemometer. As you guys can see, it will count the speed of the anemometer for every 4 seconds, and then if the wind speed exceeds the threshold, which is 0.20, it will close the window, and if it's in normal speed, it will go back to opening the window. Also, this is for the roof, so it use the sensor, it use the rain sensor, and then when the moisture level, so we use the analog pin, analog output. So if the threshold is 500, if it below 500, the roof will go to the front, and if it's more than 500, it will go to the back again to its normal state. So I think that's it for our code. I'm just gonna go straight into our model. Stop share. So now I'm gonna open my. Bisa dipin nggak, John? Video. Here is our market. So As you guys can see, this is the side where there is window, and also this is the front where in this the roof will the roof will go to the front, and then back here is our sensor and microcontroller. As you guys can see, this is the anemometer, and then this is the fan sensor. Now let's see what happens if the anemometer is spinning. I'm gonna use a fan here, as you guys can see. Let's use, this is the first speed of the fan. As you guys can see, when the speed is still slow, the window will still be open, and oh, that means the anemometer detect that the wind speed is fast, so the window close by itself. And then if we turn off our fan and the anemometer stop spinning, the window will go open again. Now let's see what happens if we put water on the range sensor. As you can see, I put some water to the range sensor. Let's see. As you can see, the roof goes to the front to cover the front yard. And if we remove the water from the range sensor, let's wait. As you can see, the roof go back to its normal state. So now let's see if both the anemometer and there is rain. Now if we put some water in here and rotate the anemometer, it goes, then the roof will go. Okay. I think that's enough.
So thank you, Lintar, for explaining the market. I think that should be enough for our project. Thank you, everyone. Goodbye.